Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to begin our discussion talking about this idea of fuzzy membership. So, fuzzy membership extends our discussion about suitability by considering the idea that maybe we have input layers that don't have good solid options for thresholds for either the binary or the suitability scale models that we've talked about so far. So just to kind of recap what that looks like, right? When we first talked about suitability, we talked about suitability as being binary, right? Where we had one threshold to make things suitable or unsuitable. Then we extended that idea saying, hey, maybe we want more levels of suitability with this idea of a suitability scale. Right, and so with the suitability scale, the idea was that we were going to classify our data into discrete classes. And we said that you could pick as many classes as you wanted, but that you had to be able to come up with thresholds for each data set into the exact same suitability scale. Right? So this was multiple thresholds. Right? And this gave us multiple levels of suitability. But we had to have thresholds. We had to be able to pick specific cutoff points to take continuous variables and make them categorical. Now, what we're going to do now is talk about this idea of fuzzy membership. And with fuzzy membership, we're getting rid of this idea of thresholds, right? And so you could imagine when it comes to suitability analysis, you have a bunch of continuous variables. Why go through the hassle of generating thresholds, turning your continuous data into categorical data? Why not keep everything categorical from beginning to end? Right? You could imagine, for example, if you're trying to get a particular species of mountain lion, for example, that you could easily come across a scenario of not being able to come up with good thresholds. Rather, you just vaguely have this idea that it prefers higher elevation, but that suitability sort of wears off as you decrease elevation. But it's not a threshold, right? It's a continuum. So fuzzy membership allows us to keep this. So fuzzy membership, right, creates continuous suitability. And so what I want to do before we dig into any particular conversation about fuzzy membership is I want to explain how we're going to approach explaining this idea of fuzzy membership. So in order for a suitability model to work, right, we saw this with suitability scale, we'll see this again with fuzzy membership, is that all of the data needs to have the same range. right? All data needs to have the same range. In the case of our original discussion of suitability, it was binary. You either were suitable or you weren't suitable, and we added those layers together. In the case of suitability scale and weighted overlay, right, we had those thresholds, but we put every single data layer into the same suitability scale. Right? Fuzzy membership is going to work the exact same. And what we're going to end up with fuzzy membership is fuzzy values, right? So to answer this idea of the same range or same scale, putting over the same scale, right, what we get is this idea of a fuzzy value. And what a fuzzy value is it's a number, it's a continuous value between 0 and 1, where 0 indicates unsuitable, and the value of 1 indicates perfect suitability. Right? But again, it's a continuous variable, so any number between 0 and 1 is valid. Okay? And so the way we do this, to make any variable we have, regardless of its original range, right, our raw data, right, and just remember, our raw data has any range. Right? It doesn't matter what it is. It could be elevation in meters. It could be amount of money in a bank account. It could be the temperature in degrees Celsius. It could be the inches of rain, right? Any scale you can think of. What we do is we feed all of this raw data into a function. And this function is going to spit out our fuzzy values. And what we're going to spend a fair amount of time talking about are these functions. Right? These functions, these control how our raw data, which has any range, gets mapped to our fuzzy values, which always range from 0 to 1. Right? We have options and parameters here. Right? This is where we have control. Right? So there are really 7 function options. We're going to talk about, and I'm going to list them all here, and then each one is going to get its own video so that we can really delve deeply into what each option does, the parameters that you can use to tweak it, and sort of what it looks like overall. So the first option we're going to talk about is going to be called linear. Then we're going to talk about something called near. We'll talk about small and large. Then we'll talk about what's called MS small, MS large, and then something called Gaussian, which is really similar to near. So again, just to recap, conceptually what we're doing is we're converting away from this idea of categorical suitability to this idea of continuous suitability, where we have each layer in our suitability data set being converted from raw data through this function to this idea of a new data set called a fuzzy value that ranges from 0, which is unsuitable, to one which is suitable. And then we have these function options that actually control this conversion process, where we're going to spend most of our time talking, because this is where we have control, right? This is the thing that we have control over, are these functions that convert raw data to fuzzy values. So hopefully this makes sense. And as always, if you have any questions, please reach out. Thank you.